All right, so let's actually go ahead and look at another example. So we're still starting off with the game of my original code word was supposed to be 1100. So my supposed code word was then going to be 1100 with the correct redundancies of 100. So here you're going to see that I'm going to receive this code word. So it's a C1, which is 1110100. So when I send this through this weird channel, this unreliable channel, we're going to have one of the bits flipped. So it's going to become 1110100. Clearly, that's the one that was switched, but we don't necessarily know that in advance. So now we want to run this syndrome game to see that that third bit, i.e. the second index, was the one that was modified. All right, so just like before, a little bit of copy and paste. So if I make these things cute and colorful again, we have my received code word of 1110100, and then the corresponding columns. So that one, and that one, and that one, emerging. And I took that same structure that I did before. So the twisty multiplication, so the blues with the oranges, the blues with the reds, the blues with the greens, copied and pasted it from before, except for I made some fancy looking ones to where the change was from before. So you kind of see why this structure is going to break down. So in that top row, I originally had a 2, which then reduced down to a 0 emerge. And the idea was because this little term right here before would have been a 0 and a 1, which would have just kicked out a 0. Now the 1 and the 1 are going to create an extra 1, which is going to reduce that to a 1, which is where that 1 is coming from. In the red column, well, it was a 0, so changing that into a 1 didn't affect anything, so it's still going to be a 0, which is good. And then that third entry, well, it was previously a 0 and a 1, which would have made a 0, but now I have a 1 and a 1, which creates an extra 1, which is then going to be this little 1, which is that little 1 right there. So the syndrome, so again, S, which was my code word times my H transpose, emerged as a non-zero entry. So that tells me that an error has occurred. And then the question becomes, okay, where did the error occur? So you look into your lineup and you see that it's this row right here is where my syndrome lives, which is my third row, or living at index 2, which tells me that my third entry of my code word was wrong, which tells me that my actual code word should have been 11000100 for an original message then of 1100. So it's really cute. It's super duper fun to play with because it feels just like you're a magician in that you're just like, go ahead, change anything you want. I don't care which one you change because I'm going to be able to immediately identify where that error actually occurred. And this will scale up very, very nicely as well. So that's basically the idea behind these Hamming 7-4 codes. In later examples, we'll begin changing that 7 and 4 into different larger numbers. So we can begin seeing what happens when the code words become a little bit longer. And you'll see that it's exactly this same structure. So we have this H transpose, which is always going to have 2 to some power minus 1 number of rows, which are going to then sprinkle through all of these different little binaries. So starting at 001 or 000001 or whatever you need to start at, all the way up to all of the ones, and then everything scattered in between those. So it's a cool little thing to see. We'll jump into some of the implementation so we can actually run this. We don't have to do this by hand over and over and over again. And you'll see that we're really just making use of some of the functions that we built up earlier in the Markov chain sections because we have this idea of matrix multiplication already in our back pocket. Now we just run it with this mod 2 structure and everything is super duper great. So I'll give this a pause and we'll jump into that and we'll see where we go from there.